Alright, welcome back everybody. In this video we're going to look at the last two examples from the problem solving with vectors lesson. Let's start here with example 3. A force of 120 pounds pulls up on an object at an angle of 20 degrees with the horizontal. A second force of 300 pounds pulls down on the object at an angle of -5 degrees. Find the direction and length of the resultant force vector. So, we have an object, and there's a force of 120 pounds pulling up on that object at an angle of 20 degrees with the horizontal. And there's another force of 300 pounds pulling down at an angle of -5 degrees with the horizontal. So that's actually 5 degrees below. Alright, find the direction and length of the resultant force vector. So in order to get this resultant force vector, what we need to do is we need to add the two individual vectors together. The first vector, if we break it down into component form, is going to be 120 times the cosine of 20 degrees. As its x component, and 120 sine of 20 degrees as its y component. That takes care of the first vector, the one pulling up with a force of 120 pounds. And the other one, cosine of 355 degrees. And so in order to find the resultant vector from these two, we're going to add these two vectors together. And so to get our x component of our new vector, we're going to take 120 cosine of 20 plus 300 cosine of 355. Let me make sure I'm in degree mode. Okay, I am. And we get 411.622 as the x component of this vector. And then for the y component of the vector, we've got 120 sine of 20 degrees plus 300 sine of 355 degrees. And we get 14.896 for the y component. Okay. Now, we need the direction and the length of the resultant force vector. First, I'm going to find the direction, or the length of the resultant force vector. That's just the magnitude of this vector. So that's going to be the square root of 411.622 squared plus 14.896 squared. And we get 411.891. As the length, which is the amount of force that's being applied to this object. And then the direction, we can write the direction in one of two ways. We can either write a direction vector. In order to write the direction vector, we're going to take the component form and divide by the magnitude. .999 Oops, what did I do? Put a parenthesis in there that I didn't need, and we've got 0.0364. So that's one way to express the direction. A better expression of the direction here is probably the angle with horizontal, and in order to find that, we're going to take the arctangent of the components. And that's going to be 2.085. So the direction of these applied forces is 2.085 degrees above the horizontal. And so the resultant vector of the combination of these two forces runs, something like this. Maybe a little bit longer. But it runs with a force of 411.891 pounds, and it runs 2.085 degrees above the horizontal. Okay. On to example 4. This is pretty much very similar to example 1. Just another expression of the same idea. We have an airplane flying in the direction 80 degrees east of north at 540 miles an hour in still air. So there's the airplane vector, 540 miles per hour. 80 degrees east of north, so it forms a 10-degree angle with the horizontal axis. It encounters a 55 mile an hour tailwind acting in the direction 100 degrees east of north. So 100 degrees east of north. 100 degrees east of north. So the wind vector looks like this one, 100 degrees east of north. At 55 miles per hour. Don't like what I did there. .55 miles per hour, and it's 100 degrees east of north, so it's a 10-degree angle with the horizontal axis. And now we want to add these two vectors together to figure out what's going on with our airplane. The vector for the plane is 540 cosine of 10 degrees, 540 sine of 10 degrees, and the vector for the wind is 55 cosine of 350 degrees, or negative 10, 55 sine of 350 degrees. And now, in order to find the new ground speed and direction, we're going to first find the magnitude of this vector, that is the sum of the two original vectors. So let's first find that vector. Here we go, we've got 540 cosine of 10 plus 55 cosine of 350, 585.961, and the y component of the vector is 540 sine of 10 degrees plus 55 sine of 350, 84.219. And so the magnitude of this vector is going to be the square root of 585.960613 squared plus 84.219 936,617 squared, 591.982 miles per hour. So there's my new ground speed. And my direction, since we're giving the directions as bearings here, we're going to do the same with the direction in our answer. So we're going to take the arctangent of this component vector, and so I've got arctangent of 84.21936,617 over 585.960,613, and we get 8.179 degrees, which is, because we're talking east of north in our original problem, I'll stick with the east of north. An angle of 8.179 is going to be 81.821 degrees east of north. And there's the new ground speed and direction of the airplane in example 4. Alright, that's the end of this video and the end of this lesson on problem solving with vectors. See you guys next time. Have a great rest of your day.